Hi students, welcome to Chemistry Online. Today we are going to discuss a very important topic. So problems also we have to discuss. So you may concentrate. So in this class we are going to discuss electrolytic cells and electrolysis. Electrolytic cell and electrolysis. So first you have to know electrolytic cell. Okay, electrolytic cell you have to know first. The cell which is used to the phenomenon of electrolysis is called electrolytic cell. So first you have to know electrolytic cell, then we go for electrolysis. Okay, so the cell which contains electrolyte it is electrolyte it is a electrolyte it is electrolyte. Two electrodes are hanged in this cell. These two are electrodes are hanged in this cell. Okay, one can be act as anode, it is a anode, and one can be act as cathode, and these two are connected with a battery. It is a battery. It is a battery. It is a cell. So it is a cell. It is a electrolytic cell. So it is a cell which is a insulator. Which is a insulator. It is electrolytic cell. So the electrolytic cell which is used for electrolysis. Now you have to know electrolysis. Electrolysis. Decomposition of chemical substance by using electricity. In this electrolytic cell, if you passed electricity, then electrodes becomes heat, then electrolyte becomes heat, then electrolyte can be dissociated into its ions. The process of decomposition of a chemical substance by using EMF, electromotive force, is called electrolysis. The process of decomposition of electrolyte into its constituent ions is called electrolysis. For example, if you take here NaCl, in this one electrolyte is NaCl, then on passing battery it is EMF, electromotive force, then NaCl becomes a decomposition 2Na plus 2Cl minus, like this it is decomposed. So one ions are attracted towards one electrode, one ions are attracted towards another electrode. So here plus means attracted towards cathode, So here cathode reactions I am going to write. At cathode 2Cl minus attracts and then gives rise to Cl2 gas and releases 2 electrons. Okay. Then anode reaction I am writing. Anode reaction. This NaCl containing water na, then H2O, it is oxidation minus to 0. Here oxidation state is minus 2 to 0. It is nothing but oxidation. Okay. Then H2O, here adding 2 electrons, releasing 2 electrons I am adding here. Then it releases H2 gas, half H2 plus 2 OH minus. It is half H2 then OH minus. So 2 hydrogens, H, 1 oxygen, OH minus. It is nothing but a reduction. It is nothing but a reduction. So here NaOH, if you take 2H2, then here H2 plus 2 OH minus. 2Na plus 2 OH minus gives rise to 2Na plus 2 OH minus gives rise to 2NaOH is formed. It is a solid. This is the way decomposition of electrolyte into its constituent ions by using EMF. EMF means electromotive force. The force is generated by a battery. Okay. EMF means the source of means the voltage. The voltage generated by a source. The voltage generated by a source in the form of electrical energy is called EMF. So it is nothing but a electrolysis. It is nothing but a electrolytic cell. It is electrolytic cell which contains 2 electrodes. It is a different from galvanic cell. Galvanic cell contains 2 half cells, but it is electrolytic cell which contains 2 electrodes in one cell. So it is a cell which is act as insulator. It is electrolytic cell. The cell is useful to electrolysis. Electrolysis means decomposition of chemical substance by using electrical energy into its constituent ions are called electrolysis. Okay. Now we are going to discuss Faraday's laws. It is a very important. Faraday's laws. Faraday's laws. The man Michael Faraday absorbed many electrolysis phenomena. Then he proposed 2 laws, Faraday's first law and Faraday's second law. So what is Faraday's first law means we are going to discuss. First law. What is a Faraday's first law means? Here we are taking electrolytic cell. Here we are passing electricity. Then here passing electricity is directly proportional to the substance liberated or deposited this electrode. Okay. What I mean to say Faraday's first law means so the amount of substance deposited or liberated or dissolved at an electrode is directly proportional to the current which we are passing through the battery. Here we are passing current is directly proportional to the substance deposited here. So that is nothing but the amount of substance is nothing but M is directly proportional to current. So Q equal to C into T. Then M is directly proportional to C T. If you want to remove this proportionality, you have to keep a constant. Then M equal to E C T. E equal to electrochemical equivalent equal to electrochemical equivalent. Okay, then in the place of E, M equal to I am going to write capital E into C into T by 96,500. This is equal to capital E by 96,500. Small e equal to electrochemical equivalent, that is equal to capital E by 96,500. So here capital E equal to chemical equivalent. Okay, this is equal to atomic weight. This is equal to atomic weight by valency. Okay, so in the place of capital E I am writing these two. So M equal to atomic weight into C into T by valency into 96,500. It is simplified Faraday's first law. It is a simplified Faraday's first law. So here first law means the amount of this substance deposited or liberated or dissolved at an electrode is directly proportional to the quantity of electricity passing through the electrode. Based on that principle, M is directly proportional to Q equal to Ct, then M is directly proportional to Ct, then M is equal to ECT, E equal to capital E by 96,500, and then we are writing like this. Then finally, so mass is equal to atomic weight into C into T by valency into 96,500. Okay, so this is Faraday's first law. Based on this, we have a problem we are going to solve. It is page number 84. Page number 84. Next, problem number 3.7. 3.7. Okay, in textbook. In textbook, very important problem it is for 4 marks. For 4 marks. Okay, write down problem I am dictating. Okay, a solution of copper sulfate is electrolyzed. A solution of copper sulfate is electrolyzed for 10 minutes. For 10 minutes. For 10 minutes with a current of 1.5 amperes. With a current of 1.5 amperes. A solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amperes. Okay, what is the mass of copper deposited at the cathode? What is the mass of copper deposited at the cathode? It is given data. So CuSO4 electrolyzed means that can be divided into Cu plus 2 plus SO4 minus 2. Okay, it is nothing but it's a valency. Cu plus 2 is nothing but it's a valency. Then here it is a time 10 minutes is given, so it is a current, it is a current 1.5 amperes is given. Then we have to calculate mass of copper deposited. Then we have a formula, then solve. MCU is equal to, it is the formula we have to use. MCU is equal to atomic weight into C into T by valency into 96,500. So atomic weight of copper equal to 63.5 grams per mole. C current C equal to 1.5 amperes. So time T equal to 10 minutes. 10 into 60 is equal to 600 seconds. 600 seconds. Then mass of copper deposited is equal to 63.5 into 1.5 into 600 by valency. Valency of copper is 2. Here because plus 2, it loses 2 electrons. Then valency of Cu equal to 2. Okay, then 2 into 96,500. 0, 0, 0, 0 cancel. 2 ones are 2 threes are. And then 63.5 into 4.5 by 965, 96,500. And then this is equal to 0.293 grams. This is mass of copper deposited. Mass of copper deposited 0.293 grams. So this is a very important problem, and this law is very important for 4 marks. Okay, so it is Faraday's first law. Faraday's first law. Okay, then we are going to discuss second law, Faraday's second law. Okay. It is a first law, and we are going to discuss second law. What is Faraday's second law means? Here I am taking 2 electrolytic cells. 2 electrolytic cell. In this one, I am taking electrolyte. In this one also, another electrolyte I am taking. These two electrolytic cells. Here electrodes are inserted. Electrodes are inserted into electrolyte like this. It is plus minus, plus minus. Okay. These two are connected with a wire and these two are connected with a battery. Okay. It is a battery. These two electrolytic cells. Electrolytic cells. Now here the amount of substance deposited means when two or more electrolytic cells are connected in a series, same quantity of electricity is passed through electrodes, then the substance deposited or liberated or dissolved at an electrode is directly proportional to their equivalent weights. Means here mass is m1 is directly proportional to E1. Here the mass of this substance deposited is directly proportional to E1. Here mass is m2, it is directly proportional to E2. Sir, mass or weight you may take. So what I mean to say, when two or more electrolytic cells which are connected in series, and then the passing electricity is directly proportional to the substance liberated or deposited or dissolved at an electrode. See here, is directly proportional to their chemical equivalents or equivalents. So it is nothing but amount of the substance, it is nothing but equivalent. So here m1 by E1 is equal to m2 by E2. So here m1 m2 are mass of substance, mass of the substance. Then E1 E2 are equivalent weights. Equivalent weights. So here what I mean to say, the mass of this substance deposited or dissolved at an electrode which are electrolytic cell are connected in series is directly proportional to their equivalent weights or chemical equivalents. This is Faraday's second law. M1 is directly proportional to E1 and M2 is directly proportional to E2, and if you take one more cell, M3 is directly proportional to E3. Then M1 by E1 equal to M2 by E2. So M1 is directly proportional to E1 means if you keep constant, M1 by E1 equal to K, M2 by E2 equal to K, then M1 by E1 equal to M2 by E2. So M1 M2 are mass of the substances, E1 E2 are chemical equivalent weights. This is Faraday's second law. Okay, very important students. So electrolytic cell, electrolysis and Faraday's laws of electrolysis, Faraday's first law, problem, and Faraday's second law. This is important for Sept. It is important for Sept, and this is also, it is IP plus Sept. IP plus Sept. So it is also. Okay. So what we discussed in this class means electrolytic cells, electrolysis, Faraday's laws. Okay. So this is briefly very important topic. Got it? If you have any doubts, you have to pack all the doubts. Sir, when college will be reopened, then we will discuss. Some students are expressing very silly doubts. Very silly doubts. This side is multiplication, so it will comes this side, what happened? Division. This side division, it will comes this side, what happened? They don't know some type of silly means basics also. So you have to learn, that if that doubt, if you ask school student, he will tell clearly. So you have to think once again, then you may get. If you are asked silly doubts, means your capability and your understanding capacity will be out. So you have to ask any doubt, I will clarify, that is no problem. So it means you have to think when you are going to ask. Okay, leaving.